So I struggle with it.
Well, I struggle too.
Okay, everybody. Hi. No. I brought this sweater in for you guys today.
It looks good. Oh yeah, it looks good. That's good. That's tight.
But it's too hot in here. Okay, so we're going to talk about test-driven development and testing and all that stuff. I have an awesome lecture for you guys, a lot of fresh stuff that I just wrote the last few days. But first, let's talk about the homework. How did it go with the mazes? Are the mazes running? Yeah? Anybody hit any interesting experiences, learn something cool about Ruby, hit a block?
I think so I had done something similar in James Starr's data structures class with like solving the side puzzle.
Yeah.
I think the part that sort of tripped me up the most is when I was trying to trace out the maze. I was trying to think of it kind of like James Starr's puzzle where I was using pointers and seeing everything. And not having those in Ruby was like really difficult for me. So I had to initiate some other types of data structures to solve the trace problem.
Yeah, you could represent any way you want.
Yeah.
Anybody else have some comments? Anybody got stuck that you want to tell about sort of what was extra challenging, or was it a pretty easy assignment? Who thought it was easy?
I have a question.
Yeah, sure.
Is the redesign portion of the assignment, is that required or not required? Because on the website it says you might not get to it, or it's unclear as to whether or not it's optional.
Yeah. Well, it's a hard question to answer because often required things are not completed. So yes, it's all required, but I know it's tricky. So and I try not to get too much into a lot of negotiation around those things. But I think it's tricky, so that's why I said it. It's probably also, to be honest, since this is an assignment I've given before, maybe left over from another class when I gave it earlier, so I want to cut people a little bit of slack, whatever. Did you not get to that part?
Oh, like that's the last part that I had to do, but I'm not sure whether or not.
Yeah, you should do it. You should do it. Not for me, but for you, as they say. Yes.
One thing that was kind of curious was just like how many ways of doing it there are in Ruby.
Yeah.
Which could be really frustrating.
For example.
A loop, for example.
Yeah.
Just not even if it's the same kind of loop.
Yeah.
It's the number of ways the syntax can be written.
Mm-hmm.
And when you're researching stuff online, you're like, oh, that's not what I'm looking for, but it is actually just written in different.
Was this like a dot each loop or a?
Art?
Was this a dot each type of loop?
Yeah,
or?
kind of. Yeah, and it's just like there's so many ways of doing it.
Yeah.
I feel like sometimes I just want to have a list of like for each is can be done 100 different ways.
Yeah.
Ways.
Yeah. It's not 100, but yeah.
Yeah.
What do you guys think? Is that a strength or a weakness for a programming language to be able to do things in more than one way? Yeah. Yeah, you.
I think it's good because every different way makes it cleaner depending on what you want to do. Like you want to access, like how you want to access items or refer to items.
Mm-hmm. Mm-hmm.
So,
Yeah.
I think it's a double-edged sword because, like, especially for people reading your code, they might not be familiar with that construct.
Right.
They might not be used to it, so there's like, you kind of lose the standardization some other languages might have.
Yeah, I mean, people talk about idiomatic Ruby. Idiomatic Ruby means kind of like the way something is done by people who are really good at Ruby. And often sometimes it's purely style, like 2 spaces or 4 spaces indentation for your tags, and it's 2 spaces, that's idiomatic, but that's really purely style. Sometimes it's that in a group's opinion, that code is more self-evident, easier to understand. I was going to write the classic example, there's a few classic examples, like some people consider, that, which is called the trinary expression. Does everybody know what this means? Look at this. Everybody know what this means? At this point, yes?
A is greater than B is fine. Yes, but A is fine.
Exactly. It's a trinary expression. You could. There's 3 more ways to write the same thing. Who wants to call out one other way? Come on. Yeah, this particular
Ternary expression.
Ternary expression is an expression that comes from. Pardon?
Yeah, it should be.
Oh, the other way around. Yeah. Okay. This expression, got me. I was just making sure you guys were awake. You were awake. But this expression has, if programming language statement structures could have DNA, this would come from the primitive ages, because it comes from C. What is another way to write this in Ruby? Just go ahead and read it. If
If A is greater than B,
yeah,
X equals yes.
X equals yes. Go
Else,
on.
X equals no. Or you can write it all like the if statement in one line,
Okay, which is?
which is like yes.
Anybody else? Okay.
Yes.
Yeah.
X equals yes if A greater than B.
Yeah. Maybe you start with X equals no. That's another way to write the same thing. There's at least one other way, I think, which is that, I'm not sure because I never use this one, if greater than B, then X equals yes. Else X equals no. And I think you need an ending. Can somebody check this in Pride while we talk?
No, that's correct.
It's correct, including the end? Okay. So here, there's 1, 2, 3, 4 ways to say the same thing. Is it bad? Whoever said that, is it bad that there's these 4 ways? Which one way would you pick if you were the language designer? What would you get rid of? See, that's one way to think about it. Yeah, go
I
ahead.
would honestly get rid of the first one you showed us.
The ternary? This
Yeah.
one? Everybody okay with that? Shall we remove that from the language? Shall I make it automatic class fail if you use that? No, that's the problem. I mean, say what?
That's the best one.
That's the best one.
Yeah.
That's the decommiter.
Well, I think I think it's a very special case of like an if and else
Yeah.
statement, because normally you nest them, you like they might be bigger than that.
Mm-hmm.
So I think that the fact that we have like special syntax for like one specific case.
Yeah. Okay.
To me, it's just I don't know. I think it takes away the beauty of the language.
Yeah. Okay. That's a fair point. Yeah. I mean, I think that, yes. Was that
Well, I was gonna say, like, in the talk from last night that we had to watch, like David goes over that there's multiple types of ways to do different things because it increases readability.
Yep.
So you'd want to pick the one to keep that is the most readable, like
Right.
if blank, then this.
Yeah.
That's very English.
Yeah.
Exactly.
Yeah.
It's not fun.
Yeah. Yes. Go ahead.
I would pick the if-else statement.
This one?
Yeah,
This
it's
one.
more universal syntax.
You would keep
also
this one.
more universal.
Yeah. Yeah.
That's a good
Yeah.
point.
Yeah. Yeah, so I mean, and you'll find believers in each of your point of view. This is a topic of debate, and Ruby has that characteristic. It's not a design goal for Ruby to be, there's only one way to do something, but there's people that consider that a very big weakness. Indeed. Yes.
Also, I know Ruby has like special things for like meta language.
Yeah.
For example, you can.
What's the meta language?
Well, it's like this language. It's sort of like this way to extend the language
Uh-huh.
by writing like special syntax, which
Yeah.
which extends the features in the language. For example, I know the I don't remember I didn't use this, but like the way to like make getters and setters in Ruby.
Yeah.
Using the
Add a reader.
Yeah, that's actually like a meta programming
Yeah.
built into Ruby.
Yeah, yeah, exactly. And that's a very powerful thing. I mean, Java is getting those, but it's not nearly
You
as
can
powerful.
actually write your own like kind of thing.
Yeah,
you know?
right. Yeah. So that's called meta programming. Meta programming is a term that means when you can write a program that examines essentially the internal state of the compiler and modifies it on the fly, which is how you can create what they call DSLs, domain-specific languages, which is kind of a language embedded in Ruby that does something else. In the case of adder reader and adder accessor, the DSL is actually a Ruby extension. But and they make it look as if it's a whole other language. I mean, you type in, people see this adder, reader, name, and they go like, wow, this is a new statement. Or they're in their mini test spec, and they write describe, test, world, do, and they have a bunch of statements that it is okay, true, must equal true, and this doesn't look anything like Ruby, but it's all regular Ruby commands. Because this is a method with one parameter. This is a method with one parameter. This is a method that was extended, added to this class. So these are all regular methods that are taking advantage of the fact that Ruby does not have parentheses, or optional parentheses, no semicolons, and the fact that you can add methods on the fly. and a bunch of things like that, you can end up creating DSLs. Interesting. Okay. What about the DHH talk? Thoughts? What do you think of that guy? Anybody ever heard of him before I showed you this talk? Yeah. What is your impression of him as a human being? What is your impression of him as a human being?
He's a nice guy.
Huh?
He's a good nice guy.
He's a very, very controversial guy, actually. Very controversial. Pardon? I haven't watched it recently, but did he do a lot of obscenities? He usually does. Yeah. But he's also brilliant, obviously. And when he saw, I think I was there for that talk. I'm not positive, but anyway, I'm pretty sure I was. And when that talk came out, it was very, very hotly debated because it basically attacked one of the fundamental tenets of Ruby programmers, which is test-driven development. Impressions about test-driven development. Were you convinced? I'm going to look at what you guys wrote, but were you convinced? What are your thoughts? Since this is the first time you probably got a lot of information about TDD. Yes?
Oh. I wasn't raising my hand, but
I know. I was calling on you.
I mean, I haven't done enough testing development to like have like a really solid thing like this is like necessarily like if I necessarily like could informatively like agree or not, but like I liked what he said like about how like it's like kind of like a magic bullet. Like, it's like it gives you all these metrics to be like that's good or not. Yeah. Which I kind of like everything like that because I think that's,
you think that's a good thing?
I mean, no, I don't like the idea that it gives like he's saying it's silly that because it just gives you all these little magic bullets to say like I know it's good because I've got like this % coverage. Like I also think that would be silly, but again I'm not super informed.
Yeah, no, that's cool.
Like
I was
100 lines of TDD code.
Sure. No, I mean, and you'll see that I'm not a total fanatic of TDD either. I think it's a very important thing to know to have in your toolbox, but it's not the only game in town. Anybody else? Impressions of the TDD gotten from that presentation? No impressions? Yes?
I mean, I wasn't so into TDD to start with.
Yeah.
So this was just like, all right, so someone kind of agrees with it.
Yeah. Did you find that you weren't into it because of a real reason or because
No.
You were just not, it was not part of on your radar, thing, right? And it's a thing that really is very strong in the Ruby world. It's much less strong in the Python world and much less strong, I think, in the Java world. But it's very strong in the Ruby world. Any impressions from you guys of the talk?
Well, I like the idea that we don't want to write our code to make testing easier. The Python code that pass all the unit tests doesn't necessarily work as a code picture.
Right, because it could be a crutch, right? It could be a crutch. So let's take a look at let's get into it. Let's take a look at the website. So I'm going to just look at it here. You're going to look at it there. So and I have much too much information, so I'm going to probably edit. See, look, it goes on and on. Forget it. I'm going to go fast in this section. I'm sorry?
No, I was just looking at his Wikipedia page, and I thought that he started Rails when he was like 18 or 19.
Yeah, how old are you?
I'm 19.
Okay, well, chop chop.
Sorry, you're slacking.
No, he's 19. He's 18 or 19. He's in there, yeah. People do amazing things when they're 18 and 19. So, yeah, he's a very impressive guy. Extremely smart. Okay, so what's the mumble shared with you? What?
So this guy is basically Buckaroo Banzai, right?
He's what?
So he like does photography and race car driving.
Oh yeah, he does race car driving. Yes, exactly.
So he's basically Buckaroo Banzai.
I didn't see that movie or read that book. I've heard the name. So what is Buckaroo Banzai's connection? Does everything well?
Oh yeah, he's basically a neuroscience. He's like a neurosurgeon, a rock star,
right?
A test pilot,
right?
And probably a karate master.
Yeah, he's like that. Yes. Although and if you look at his Twitter feed, he's always taking pictures of himself with his helmets and his racing outfits and all that stuff. But I never really know what to make of it. I really don't. But anyway. So the interesting thing about testing is that if you look back at the history of software quality, there was a time when testing was kind of the thing you did before you released the product. In fact, there was a time when testing was done by people just typing away and saying, okay, I'm going to read a specification that says, just create a new contact in my contact app. I have to click this link, and it should display this, and it should fill out this blank, and then I should add a contact, hit save, and then it should be there. And they would write that down, and some poor person would sit there before the product was shipped and do this, and then write down a report saying that it succeeded or failed. And then it would go back to the developers, and they would try to fix the bug. And that's how it began. But in the world of Agile, this is a trend that has been going on for the last probably the particular trend 5 or 10 years. The transition away from individual releases, the transition even away from very fast releases, so that now if you look at a site like LinkedIn or Facebook, they really don't have releases. They basically are releasing all the time. And so the idea that says when we release, we run the tests is kind of gradually falling away. And so the whole notion of automated testing becomes much more important, and as we've seen, that's kind of where TDD sort of began. In fact, if you trace it back, around when the Agile Manifesto was written, which was like in the 80s or 90s, I forget when, is when testing sort of became more and more of a thing. Automated testing. I mean, there always was testing, but it was quality assurance. As you're going faster and faster, testing becomes a requirement, okay? Automated testing, rather. Now, the next thing is, think about that. So that's testing as a way to ensure quality. Testing as a way to ensure that my site does what it's supposed to do. The second thing is testing as a way to assure that you have a good design. And that's where TDD comes in. The exercise, it's not even TDD actually, because you can do it in any order, but testing for the purpose of design is when you write an automated test that says, my user model needs to be able to reject a user that has a name that looks like this, needs to be able to only accept up to 3 courses per student, et cetera, et cetera. And then you write a test to verify those assumptions. There's a design benefit that comes from that, because if your test ends up being a gnarly mess, it's going to tell you that probably your target class or object or subsystem is a gnarly mess. And so the act of writing tests reveals that. Conversely, if I told you, please write me a class that allocates my course schedule, the courses I want to take against my calendar, and make sure that I don't take any courses that overlap, and I pick that as a relatively complicated iterative algorithm, then I bet you 2 things. I bet you that you will have lots of bugs in it, and I'll bet you also that if you wrote the tests first, in other words, you just thought about, okay, I think I need a calendar object, and the calendar object probably has to have an add event, and a reorganize events, and a remove events, and probably an event should have a method that says something like check for collision, and you go on, and then you challenge yourself to try to write tests for those, even before the code does not exist. And you write the test, and in writing the test, you'll see that your first idea about what the way the classes were supposed to be was incorrect, and you then modify your test, and then you go write the code, you end up with a much better design. And so to me, that's where the test first idea really works very, very well. When you have a class or a collection of classes that have something a little bit intricate about them. And intricate is not, you very easily get into intricate. Like if I told you, I'm going to give you an array, and I want you to fill it with ones on the diagonals, but not the diagonals that go the wrong way. I bet you, even though that's very, very simple to write, and you probably have a couple of nested loops, you would get it wrong the first few times. Mazes, the same way. Who wrote some tests before you implement any part of mazes? Anybody?
What do you mean writing tests?
What I mean by writing tests is wrote a method which was not part of the functionality, but called the functionality, asked it to do something, and then checked the results to make sure they were correct.
I wrote like a print statement.
Okay, that's not a test, but it's, but you're with. I didn't mean to make fun, because 80% of programmers, that's how they do debugging, print statement, and they're much less efficient and effective as a result of that. But there's lots of opportunity in mazes to actually, and I bet you would have accelerated the work a lot. To say, for example, you might have had something. I'll get to it in a second. You might have had something. Create a new maze that's 2 by 2, or here's a random string of 1s and 0s. Try to import it. Do a short one first. Do a longer one later. You would discover bugs earlier, and if you discovered bugs in the basic algorithm which just managed the maze, let alone creating paths or finding them, If you found those bugs before you started looking for paths, you would have saved a lot of time. Go.
So I mean, I did the same thing. I just did for instance,
Yeah.
like constantly. And I mean, sure, it probably would have been more efficient to make a test, but I just didn't know how to write the proper test for it, and this was just easier. Wasn't wasting time writing a test when I was just doing it.
No, and yeah, exactly. And it's really a technique that that I'm trying to build into your toolkit. And as we go forward, maybe we'll even go back and look at Maze and add tests to it. Okay. Okay, and the final thing that's really important about testing is refactoring. Now we'll talk more about refactoring in a subsequent class, but basically, who's heard the word and wants to venture a little definition of it? Yes.
You're taking existing code and restructuring it to be more. Better, and that fits the requirements of your current project. Then you're restructuring to meet your current requirements.
Yeah, exactly. That's half of the definition. Yes.
It has to do with changing the method signatures in your code.
Well, there's many ways of doing what he said, which is to make the software. Like, let's say, if you have a method that goes 25 lines, that's a prime candidate for refactoring into a few methods that are shorter. Let's say you have some method signatures that have 10 arguments. That's a code smell. You probably want to refactor so you have fewer. There's a lot of things you can do to make your code better. And the motivation for making your code better, just as a reminder, is not just the pure intellectual joy and aesthetic joy of making more elegant code. It's also to save money and to save time. Because except for apps, for software that's meant to be thrown out at the end of the semester, most software actually ends up having some bit of a lifetime. And if you can structure your code better now, then when you have to modify it in a week, a month, or a year, you're going to save a lot of time. So that's the reason. But the second very important part of the definition of refactoring is small changes made to code in order to make them better designed, which do not change the functionality in any way. That's the key. You can't call it refactoring if the functionality of the method is going to change. And so in other words, if I have one way to compute a factorial and it's really convoluted and ugly, I can refactor it as long as it still computes the same exact factorial, and on. Or my class scheduling algorithm, all those things. Okay? And the reason I bring all this up, and we'll practice this in subsequent classes, is that testing is very important, because the canonical way of doing refactoring is, before you even touch the method or the class, make sure it's got good test coverage. Make sure you've got 5 or 6 or 10 tests that verify that the class does what you think it does. Then refactor and make small changes, change a few lines, and rerun the tests. And as long as the tests keep on working, you know you haven't broken anything. And people say that the big win when you do that is it gives you confidence and it gives you courage. Because if you have a big system, like your products are going to be big by the time you're done, and somebody's going to go like, instead of using a string here, I think we ought to really use 2 strings, one for the first name, one for the last name. And you go, that's a good idea, but I don't want to touch it because I'm scared I'll break it, which is classic. Well, you get courage if you know you've got tests. And as long as the tests keep on running, you haven't broken it, okay? And that's the strong connection between refactoring and testing. Okay. Going on to good testing and testability. So I just talked about that. If you have good test coverage, it allows you to make changes to the app, and the reason that's a good thing is because apps always have to change, and if the app is badly designed or you don't have good tests, the changes get much more expensive. Either they're wrong and you go around in circles, or they take a long time to decide, or you don't even do them, and so you end up staying with an inefficient algorithm because you just don't dare. And believe me, I don't know if anybody's had that experience, but you will. When you have an app or a piece of code or an algorithm which is so intricate and it just works, you're going to say, I'm going to put up with this ugliness because I don't want to change. I don't want to touch it. Let's talk about commenting really quick. So what are your, I mean, it's on there, but what are people's habits these days about commenting? What have you been taught, or what are your particular preferences about commenting code? Yes?
I mean, I think this is kind of obvious, but programmers, sorry, in my experience with people I've worked with in like the last 2, 3,
Mhm.
whatever years that I've been here,
Mhm.
programmers who are obviously a little more comfortable tend not to comment whatsoever. Before kind of beginning, tend to comment through a lot more.
Uh-huh.
Because I know I work with like a couple people, including this past group, on a different project.
Yep.
And they just assume you'll understand.
Yep.
Like, oh, it's obvious enough. I
Yeah.
was like, if you had just commented, I would have had to go through everything to understand exactly how it connects.
Right.
And it's like not even 30 seconds worth of just a quick comment can save you up to 5, 10, 15 minutes.
Absolutely.
down the bit. So I've noticed people tend not to comment unless they're a little nervous.
Yep, yep. Anybody else have a philosophy of commenting? Yeah.
I don't know if this is like best practice, but what I generally do is like pump out all of the code, and then when I want to take a break from coding, I'll go through it and commenting it, just because I find it's a waste of time to comment some code that you're just gonna end up deleting at some point.
Uh-huh. And when you say you go back and put the comments in, how do you know where you need to put a comment?
Anything that's not like obvious, like if it's A equals like some list first index, I'm not gonna comment it like take the first index of the list and store it to
Yeah,
A.
yeah.
I think as long as you are very good with modularizing your code and naming everything clearly, you don't need to comment everything. I still think comments are necessary in some places, but I don't think that they're as necessary as people say as long as you write your code well.
Yeah. Any other opinions? Yeah.
I think if you have to write comments for a piece of code, it's probably that piece of code that you wrote is way too complicated.
Yeah.
And you should try simplifying it.
Yeah.
It's
Okay.
It's a sign of
So you're in favor of the best code with no comments because it's so clear.
Yes.
Okay, gotcha. Oh God, got some fights here. Yeah, go ahead.
I usually just start with like one line of comment per method, and then at the end I go through and I look how how readable it is, and if it's not very readable, then I'll comment it out.
Yeah.
But if it's so unreadable that I have to write like multiple lines of comments for that one thing, then I'll just actually change the thing.
Yeah. Hey Jacob, have you heard back from LTS people? Could you
Did you contact LTS or MTS?
Oh, I didn't know what MTS is. So.
Okay.
What is MTS? Media
Technology the people who do this.
Okay. Are you connected with them? You look like you know a lot.
No.
Huh?
We all work for LTS.
Can you guys make this fixed?
No, that's MTS.
Do you know somebody at MTS?
LTS.
Do you know somebody at MTS?
They have a hotline for this particular.
What is it, 64632?
Yeah, that sounds right.
You,
64632.
Thank you.
Yeah,
Sorry.
you should call it.
Yeah.
They'll come on.
Make it better because soon I will need the screen because I'm going to be doing coding. It's going to be very unpleasant for you guys. Yes.
Call them on that phone.
Pardon?
You can call them on my phone.
No, I want to keep talking. I want somebody to do that outside. I don't want to waste a second. I got a lot of stuff to go through. Did you have a question?
I just realized answer.
Self-answer. Okay. Anybody else? So yes. Yes, sir.
Same answer, but what I was gonna say is in the beginning of a code, of a class or something, like a general explanation.
Yeah.
What this file does.
Yeah. So was it? No? Okay. Yeah. Okay. So it's very controversial. First of all, you'll find people to argue about this forever. So it's not a cut and dry thing. But the trend among professionals is to less comments. And one of the notions that I read about, which I think makes a lot of sense, is if you have a section of a method, 5 or 6 or 10 lines that need a comment, because they're not clear, that's a good candidate for refactoring that into its own method. Okay? And taking that method and giving it a very descriptive name. There's the most fundamental kind of the refactoring sort of move. I mean, there's books written about refactoring, like patterns, ABC. So the most fundamental refactoring move is called extract method. And basically how that goes is like this. It's a very particular way to do it. And I'll show this to you in code. But it's very obvious. I mean, it's nothing too profound, but if you do it in the way that I'm going to show you, it's very safe. So let's say I have a method here. And it has a lot of lines. Okay? And you think that these lines here are a paragraph that maybe need a comment. So they're probably a good candidate for refactoring and extracting the method. So what you do first is you write a new method called def, whatever the comment said, my sub method, N, and you copy, not cut, those lines into here. Next, you examine these lines to see what variables they access, okay? And you make those those parameters of this thing. Okay? Next, and then you run the test again, make sure it still works. Then next, you say, okay, everything looks good, nothing's broken. You go to one site, because this is also classic if you have a non-dry code, so it's a repetitive pattern. You go to one site, and you erase those lines, and you put it to call to my new method with the parameters. And you run your test again. And they still work, you pulled it off. Now, sometimes this thing may have like 10 or 12 variables that are being used here. And that's a code smell. That says to me that maybe these lines are not as tightly coupled to each other as you think they are. So they may not be actually a very good candidate to pull out. Or there may be a parent object like some object that has parameters that you can use instead of the individual variables. But that's the basic move. Take the lines, put them in another method, don't delete them from here, get it to run, identify the missing variables, make them parameters, write a test for this thing now. Test. Make sure that this does what you think it's going to do, and then go and do the one. So, and that's like the number one refactoring move there is. Anyway, yes.
I got an email from Tim. He's sending in person.
Thank you. Okay, great. Excellent. Okay, so right. So that's about comments. So my code does have comments, but not a lot. But it does have comments when sometimes there's a reminder because I'm doing something that I'm not sure is like kind of convoluted. Although again, the kind of code that needs a reminder is things that look like, A equals C bracket D bracket 1, comma 4. Okay? Yeah, this may need a comment, but I say it needs to be rewritten. This is like so error prone, it's not even funny. People call these magic numbers. Who could say why they call them magic numbers? Yes?
They don't have any explanation to what they are, so they're just like, they come out of nowhere. That could be a 4 and it wouldn't even matter.
Right. So basically these are numbers that have and you identify magic numbers, there's low magnitude integers in the code. That's always a sign that there's something going on that's very, very brittle. Certainly with arrays, off by 1 errors are tremendously common. Suddenly the position 1 became position 2 and the code breaks, there's no test to detect it, it's full of magic numbers. But so code that needs a comment looks like this, and you can try to fix it by saying C is a 2-dimensional array, an array with, 2-dimensional array with, or a hash or whatever, explain it, and then B, explain that, and position 4 is the rating, blah, blah, blah. But like in the movies file that you guys read in, I would say a good solution would be, as soon as you read that row in, at the earliest possible convenience, where the position actually has a meaning, this is the user ID, this is the movie ID, the sooner you can get rid of those numbers and put it into an object where those different things have semantic meaning, like movie ID or so on, the better. The longer those indexes in that array survive in your code path, the much more error prone you are. Okay. Okay. Talk about the testing pyramid really quick. The testing pyramid is just a metaphor. There's a bunch of different kinds of tests, and I've talked about them in the past. There's unit tests, system tests, integration tests, scalability tests, blah, 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 blah. Some tests are very fast to run, so they run quickly, they finish quickly, and you end up, well, let me just draw the pyramid, because I didn't want to figure out how to draw a pyramid in text over there. So basically, if you look at the pyramid, there's like speed slower and also more brittle. What does brittleness, what might brittleness mean in regards to a test? What would make a test brittle? Versus robust would be the other side of that spectrum. What do you think would make a test brittle? Yeah.
A small change would cause it to fail.
Yeah, it's very dependent on some intricate detail of the algorithm, and a very small change might actually cost 100 tests to change, because I was depending on something that might change very easily. And so and then of course there's tests that are slower or faster. And what that means is it's very, very common for a big system to have hundreds, if not thousands, of tests. And some of them will run in 1 millisecond, and some of them will run in 5 seconds, and some of them will take a minute. And so if you embrace the philosophy of testing after every commit to your source control system or every deploy, whatever it is, you're going to be concerned about how long it takes to run the tests. So if you look at this pyramid, it says you should have more of the ones that are fast and more of the ones that are not brittle. Okay, so if you fill this in, and again, experts will question exactly what the layers of this cake are. Everybody agrees the lower one is unit test. And everybody agrees the top one is UI test, which is to say something is actually clicking links on your screen. But in here you will find things like integration test, or service test, or various other names. But that's basically the idea. And that's why people end up writing more unit tests. They run faster and they're more robust. Now, what makes a unit test a unit test? Generally, that it's testing the behavior of a single class. Sometimes it's testing the behavior of two classes. But basically, it's not at all in contact with the environment of your whole application. Okay, so you can make those tests, you can run those tests without the application even be running. Those are called unit tests. And by the way, it's as you get into writing more tests, I'm going to try to get you guys to do it just to experience it. You will see that, and you may experience this funny feeling like, geez, it took me an hour to write the code, and it's going to take me another hour to write the test, and basically the test is like the code turned inside out, and it feels repetitive. And so it becomes important, and that's where the DHH talk hits a chord, or hits home. At the point at which writing tests becomes an obsession, where you do them just because that's what the orthodoxy says you need to do, it's at the time at which you become less and less efficient. So yes, at the beginning, I'm going to ask you to do tests a certain way at a certain time, but as you get more experience, the things that I hope will happen is you will appreciate the value of tests, and you will start writing them yourself, not because you must, or because you have this sense that a good programmer writes a million tests, but because you see the benefits. Okay. Now we're going to talk a little bit about some testing techniques, and I wonder whether I should just show this. Yes. So there's this let me just show you actually instead of talking. Oh, I can't show you. Actually, yes, I can. Click on that thing that says Doubles Demo, that link. And let's look at the double demo number 1. You can look at it, I'm looking at it.
Number 1?
Yeah. So there's a class called book, and it has, and by the way, this is using, Minitest. Let me see if this is the one I want. No, this is not the one it is kind of the one I want. So imagine, right, that book is actually a class that's part of your system that's actually an active record class that stores to the database, and so on and so forth. Okay? Oh no, I take it back. Flip it around. What I want to test, now I remember, I can't look at it. Now I remember now. So basically what I'm trying to test is the book class. The problem is that the method that I'm trying to test is the book.new method. If you look at that on line 19. I'm trying to test the book.new method. However, the book.new method requires an instance of an author object. Right? Okay? You with me? And the author object is this big honking thing that takes a whole bunch of other setup to make it, hey, you have to put together a profile, you have to put together an image. It's a complicated thing to create. If all I'm trying to do is to figure out that the book.description method properly pulls the title out of the book and the author's name out of the author object. That's the one thing I'm trying to test. Okay? The book.description method. Well, I'd have to go and create this author object, build all its requirements in, and if all I want to do is to figure out whether or not the book.description works. So what do I do instead? I create what they call a mock object, also known as a test double. And again, there's a lot of variations. Don't worry about it for now. So what do? So many test frameworks, including Minitest, have a mocking subsystem. A mocking subsystem is this is very Ruby because it's using metaprogramming, a way to create out of thin air an object that behaves a little bit like an object you need, but only along the dimension that you're interested in. So look at the line that says, line 14, at author equals, minitest mock.new. Create a new mock. Okay, I haven't even done a require on the author.rb file because I'm not even using it. Okay, I'm just creating out of thin air an object called a mock, and I'm assigning it to the variable at author. Okay? Then I tell it, hey, at author, if you get asked, if a method gets called on you, .name, so if somebody says at author.name, always return Tim Hickey. So now I have an object in at author, which does only one thing in the whole world. The only method it responds to is .name, and the only answer it ever gives is Tim Hickey. So you can see that it's sort of a pathetic subset of a real author object, but it only took me one line to set it up. Now with that setup, I can actually write my test. It can build a description. I say at book, because the class that I'm testing is the book class. We sometimes call it the system under test, the SUT. The class I'm building is book. I'm testing is book. So I say book.new. The book is called 3D graphics. The author is at author. It's not really of class author, but I happen to know that the book code doesn't really care or know or have any way to tell. So the book code, the description method in the book, which is what I'm trying to test, is going to ask this at author, what's your title? What's your name? And it's going to glue it with the name of the book and return written by that person. Okay? So that's a very, very simple example of mocking. Did you have a question? Yeah, okay. It's totally clear to everybody? And you'll find sometimes, if you look in your, they tell you how to fix it?
I'm just going to start looking at it.
Okay.
Because
they're not coming.
10 minutes ago. And
what was I saying? Oh yeah, so if you think about your mazes or your movies or whatever else, if you had to write a test of one thing, and that one object depended on another object of a different class, and that object of a different class was kind of hard to put together because you have to read in a file or you got to do something else, you may not actually want to be exercising, doing the work to set up that other class. Another sort of more philosophical or conceptual point is that people try to make sure that a test is only testing one thing at a time. And if you use the actual author class, something happened. If you use the actual, but you get a picture of the question. It's just blue. If you use the actual author class, then actually you would be testing two things. You'd be testing not only whether the book class was doing the right thing in the description, but you'd also be testing whether the author class was doing the right thing. And if it failed, you wouldn't necessarily know whether it was the fault of the author class or the book class. Yes?
What does the @author.verify do?
Okay, the @author.verify is the one that's going to say, please tell me that you were actually called. Huh?
What do you mean?
Well, remember the @author is a fake, it's a mock, right? And it's been told, if you get called this way, return that. Now what if there was a bug in the book class that when you ask for the description, it just always returned written by Tim Hickey, without even asking the @author. So this is an extra level of testing that says, okay, not only do you return the right string, but you return it by making that call.
By doing .name.
Yes,
okay.
Exactly. Good question. Let's look at the other one. Okay, this time we have a class called order, and it basically does what? It can hold a list of items. You can add an item to it. You can compute the total by adding together the price of all the objects on that list. And you can compute the net total by multiplying the gross total by 1.05. Okay? But importantly, it wants to have a list of objects on it. Oh, he fixed it. Awesome. Did you do something special, or did it just wait? Maybe they rebooted from the other side. Excellent. So basically, this thing is expecting, so much better to be able to point. It's expecting a list of things that respond to the method price. Okay, but these things may be things that come out of a database, maybe even from a different service. Who knows? Complicated. You don't care about that. What you care about is whether you wrote this correctly. So what you do, you say, I'm going to create a new order, and I'm going to create just a simple array, nested array, shoes 12, socks 6. Okay, and I'm going to now iterate over this list. This is a static. This is like a text fixture. A static list of value pairs, name value pairs in two nested arrays. And I'm going to say for each one, of which there's only 2, I'm going to say, okay, create a mock item. And I'm going to say, if you get asked for your description, please return shoes or socks. And if you get asked for your price, please return 12 or 6. See that? Everybody see that? It's very obvious code-wise, but it's a little bit subtle conceptually, what I'm doing here. Okay, so I have an array, which is kind of the initialization data that I'm going to use to create a series of mocks. And I'm going to walk through that array, and I'm going to create one mock for every entry at the top level of that array. Okay, do you have a hand up?
Yes.
Okay.
So item.expect in the context of a before block.
Yep.
In mini test.
Yep.
It's an assignment to an object.
Yep.
Rather than okay.
No. Let me be clear. Remember that item is created here as a local variable.
Okay.
Okay, and it's basically every time this loop is called, it's going to visit this list twice, once for each one, and it's going to create a local variable with the value with a mock in it, and it's going to tell this guy, what to expect, and then it's going to go and add to this instance variable that does survive the result of add to that list, the result of that. So once this before block runs, the result is essentially, and the only result that these guys will see is an at order instance variable that contains an order object that happens to have these 2 items on the list.
Okay, but why don't you just do item.description equals item info 0, like the first item?
Because there's no item class. This item class is a fake.
Oh, okay.
So it's a mock. It has no logic. You can't say item description, so I don't know what that means. So it has a few methods that are built into it because it's a mock, and one of them is the expect method.
Okay.
Because it just says, it's like, I'm a dummy, you're going to tell me when this gets called, return this. Okay, good, I got it. And so on. And now, down here, we see that I called at order, gross total must equal this. And it's going to use these mocks, and I don't even have to include well, we don't even know what they are, whatever the data types are of these things. By the way, this is another bit of good design that I want to point out. You can tell, there's a principle of single responsibility principle, which is like everything does one thing. And one of the telltale signs is how many objects, how many other classes are needed for this class to operate. And by looking here and seeing that this is not pulling in any other classes, that's a good sign. It means this is very isolated. And by looking at the way this is written, that the order class can actually do its job without requiring any other definitions, any other classes. That's good too, because it means this guy is very isolated. So isolation is good, okay? And so this is just testing that. Obviously, you wouldn't have to put in the before. This would not really require before block because there's only one test there, but the idea was to show how it worked later. Before blocks get called, so if I have 100 tests here, before each one, the before block gets called. Okay? Another important thing is tests should all be independent. That's why when you run mini tests, it scrambles the ordering of your tests. It does not want you to write test B that assumes that test A has run. Why? Because you want to be able to run one test. Okay. So that's a mock. Yes?
So it's a mock object is basically a hash.
Well, it's a little more than that, but yeah, probably that's a key part of it. Yeah, because they do a lot more things. I mean, you can say mock, you know, expected to be called or be called with this parameter, or if it's called with a 1, then return this. You can basically instrument it to do a lot of stuff, but it's all fake. And then you can tell it, what do you want to happen? Like you could say, I want this method to be called once and only once. Or you can say, I want this method to be called 0 or once, but no more. Or you can say this, I want this method to be called 5 times. And so you can go further and further in sort of indicating your assumptions.
Can you also add your own defined functions to it?
Well, you could, but at a certain point, you might as well write a class. I mean, another variance of mocking, by the way, which is not illustrated here, is you could just write a class. I could have just written a class called item and did a few things and used it because, you know, Ruby doesn't really care and know which particular definition of item you're using. So you could, and I'll show you an example of that in a minute. Nope. Okay. Let me show you a couple of examples out of my own code, a little old code of mine. This is written with RSpec, but don't worry about that. Yeah, sorry, was there a hand?
No.
Okay. So let me remind myself what this says. Oh yeah, here's the example, exactly. So I have a fairly complicated class, which I'm not going to get into, but it needs, this class down here, needs another class to work with, which is the n item. And I didn't want to pull in the whole n item class because it was very complicated. So what I did was I wrote a little baby n item, and I called it, this is just naming, I called it ni mock. And I gave it only a few parameters, a few methods. And that was enough for me to then use it in testing the app, because the particular thing I was testing only needed these two methods. So another way of testing is literally just create a subset of the class you want that's independent. Now, one of the things you'll see in both these examples is already my tests have a dependency on, I think it's working again. It looks like it started working again. Jacob fixed it? What did you do, Jacob?
I just followed the documentation that was on the site for some of it. I pressed the PC button and waited a bit, and I pressed the HDMI button.
Weird. I just like went off the source and back to the source?
Yeah.
Huh.
Wait, you pushed the PC button and then back to the laptop
I
button?
pressed the PC button, waited a couple seconds.
Yeah.
Then I pressed the HDMI button. There
Yeah.
might have been button or two I pressed in between.
Which I did all that stuff too.
Something weird has been going on
Yeah.
in here, which I'm trying to figure out.
Yeah, no, so basically when I was doing it, this wasn't on, or it was on in blue.
Right.
I saw my Mac screen on here, so I know that this was connected correctly.
Right.
But it wasn't showing up there. And then about half an hour later, Jacob did the same thing apparently, and it seems to have.
So when I pressed the PC button, the PC display turned dark. And it was just like this MacBook that had the screen. But after the HDMI button, the PC display came back on. I'm not sure why that was.
Well, do some more extensive testing in here once
Okay.
class is done.
All right.
So sorry for the trouble. But
Okay.
that is working
Thanks
out.
for being responsive though.
Sure.
Okay. Want to show you something else here? I just want to show you techniques, because there's things that are straightforward Ruby, and yet you may not think of combining them in this way. That's why I'm showing you. Okay. So there was that ni mock method, a class I made up there. Here I have a constant variable called cases, and it's got 4 arrays in them. Each array has 1, 2, 3, 4, 5, 6, 7 strings. Okay? And here I go through a loop for each case, and I say ni mock, which is the thing from there, new, and I give C0, C1, C2, this, and this, which initializes that mock, which is just a regular class. I just called it mock. Okay? And then I do CI equals CItem.new ni, which is what I just created, And then, remember the C is the variable that's being changed as I walk through this array of cases. Then I write my expectations. I say expect ci.title to equal C bracket 3. C bracket 3 is 0, 1, 2, 3. So what I'm testing here is that the CI class, not the NI class, which is the one I don't care about, CI class is properly parsing the string and finding term overview over here. Okay, and then there's other things I'm checking. So I made an array that simply has strings of initializations variables and results variables, and here I just check them. You follow the technique? And that's just one, but I just want to show you interesting ways you can combine these things. There's nothing complicated here except for the idea of how to do it. Okay. Yes, sure, please.
What's the benefit of doing like expects and things like that rather than just printing out like dot title or something and just seeing what it is? And
Okay, the advantage is that this code will fly unless there's something that you don't expect. First of all, if you print it out, you'd have to remember, and you would know where you would, because you see a bunch of text, whatever. But more important, there's two more important things. One of them is that if it is what you expected, you wouldn't see anything. So you'd only see the ones that violated your expectations. And secondly, when you run things under Minitest, there's a very robust exception catching thing, which says if one test blows up, it still runs the other ones. And so you don't end up like, oh, I only made it this far, so those are some of the. So it's really, really different. And I'm going to ask you guys to write a test or two just to get a feel for it. Okay. How am I doing on time here? Ooh, we only have 20 minutes to go, right? Am I right?
Yes.
Okay. All right. 15? Oh, you're right, 15. All right, I'm going to skip fixtures. And maybe I'll do this another day, because there's a lot of stuff here. Let me start going, see how far I get. How about that? So I'm going to show you an example, because you guys are all doing Rails. I want to show you how all this stuff comes into play in Rails, okay? So here we go. Maybe what I'll do also is I will make a recording of my doing this, so you can watch it at some point. Oh wait. So I'm just gonna do, these are the commands on the left that I'm gonna do, okay? So here we go. Ooh, where's my mouse? Hello mouse, where are you? Oh, there you are. So I'm just gonna create a new Rails app. Rails new my app, CD to my app. I'm going to add some very handy gems to my gem file. Okay, so I'm going to subble here. Boop. Kill this. Kill this. Okay. And I'm going to go to my gem file. And at the end, I'm going to add these very handy gems. And I'm going to do bundle. So whenever you change your gem file, you got to run bundle. That's going to make sure you have the gems you need, and if you don't, it's going to pull them in. Okay? Now I'm going to ask to generate a model. And this model is going to be a little game, when it's all done, to learn words. You're going to have words in English and words in Dutch, and you're going to learn words with this app. That's what this app does. Okay? So I'm going to generate a model that's going to be called Word. It's going to have only two columns. English is a string and Dutch is a string. Two columns. And I did break DB migrate because whenever you add or change migrations, you got to update the database accordingly. And by the way, you're welcome to try to play along if you want. Now, I'm going to get interesting. I'm going to go to the word test. And if you look at your standard directory in Rails, you will find, it changes a little bit depending on the version that you have, but models, you'll find word test in here. And Rails will create a blank test for you just to show you where it goes. Does nothing. But if you in fact, well, I will get rid of this. So I want to just replace that with my test. Okay, just cut and paste. This is going to verify, this is very handy to verify you basically have things set up correctly to do a test that you know is going to work that doesn't do anything. And then you can just make sure, run it, and see, oh, let's see, okay, it failed, and it failed because it could not find the table words. Okay, why is that, I wonder? Did I do a regularly migrate? I did, didn't I? I did. Word, could not find the table. That's amazing, because this worked before. You know that story, right? Let's go to the shell to see if I do just rake here. I get the same error. Let's pretend the other one didn't happen. So I typed rake by itself here, and what rake by itself does, you'll tell me when I'm out of time, okay? Tell me when I have 3 minutes to go. When rake by itself, you run it, it's going to run all your tests. All I got is one dot, because this whole product so far has only one test. And the test is a test if 1 is equal to 1, which I would expect to pass. Okay? Now I'm going to make it a little bit more complicated. I'm going to add another set of tests to this particular test file. And the way you read these files in test unit and test unit spec is describe kind of defines a set of related tests. In this case, instead of you can have a string there that just says test the word class, or you can just put the name of the class there by itself. Then the do end block is all the tests that are related to that particular describe block, and it contains 2 it blocks, and each it block is 1 test. Okay? So the second one says, I'm going to verify that my class just is, and you start like this, does something very simple. Is it actually able to store a word? So I do word.new, and this is active record. English is house, Dutch is huis. And that word now becomes the local variable that contains that word, that single translation. And then all I say is, I want to make sure that when I look in there, I find the 2 words I expect. So the first line 10 creates the word object, and 11 and 12 checks that it does what it's supposed to do. And I go back to my, and I run it, and I got 2 dots. 2 tests are running now. Okay? All right. Now we're going to add some fixtures. And the part I skipped in the lecture is what are fixtures? Fixtures are basically test data. And there are many different kinds of test data, whether they're stored on disk, in a file, they're stored in a database, they're just created on the fly within the test. There's any number of ways, but the characteristic is data that is created just for the purposes of testing. It has no other purpose, and in fact, you want to make it disappear when the app is done running. Okay? So Rails happens to have a very convenient mechanism for fixtures, and it's called, hey, where are you? Where the hell is my mouse? Okay. It's called fixtures. And it's a simple YAML file, which looks just like JSON, that says house. I want to create 2 records in the Word database, and you know that because the file is called words.yml, and the first record is like that, and the second record is like that. And that will be automatically created for me before my test runs. That's why it's a test fixture. So if I need 10 words to get the ball rolling, I can stick them in here. And they'll always be there when I run my test, and they'll never be there in production. So they won't pollute your actual real code. Okay? So now I have 2, with that now I should have 2 words built into the database only when running in test mode. So I go back and now I'm going to go back and I'm going to add some tests to verify if in fact that's true. I'm going to add first this one. I'm going to go back to my word test, and I'm going to say, okay, furthermore, I expected that there's 2 words already in the database. So the database is actually able to store words. So I'm going to talk to the word class, which is active record class. I'm going to ask for a count, how many there are, and I'm going to say it must equal to 2. And when I run that, now I have 3 tests. And if you read the fine print, it says 3 tests were run. They contain between them 4 assertions, because one of them had 2 assertions. Everybody keeping up? Anybody lost? Anybody want to ask a question? Anybody on their iPhone? Okay. Let me do one more, and then I'm going to stop for now, but I'll pick it up on Tuesday. So I'm going to add finally that I'm able to store a new word in this database. What do I do? I say word.create. It's regular active record. English is shoe, Dutch is schoen, and then I say I better have 3 shoes now. 3 words in my word database. So if I run this, I should now have 4 runs and 5 assertions. So all my tests are passing. People call it, I have green. All tests are green. That's just a lingo. Okay, and you can see here, I could run, according to this, 131 tests, and this doesn't matter. This starts mattering when you have thousands of tests. Okay? Now, before I stop, let me ask you a question. What else might you want to test other than this to make sure that it's properly accepting a new word? What other tests might you, what other thing might you be curious about? Well, there's 2 words. Then I added 1, there's 3. What else do I want to know to make sure it's working correctly? Well, I might want to know that, yes?
There are 3 English ones and 3.
Yeah, well, each word has 2, but the words that I put in are there. That actually, if I do a lookup for a word with English's shoe, that I would find it. So we can actually quickly write that test. I just put it in here. Word.where English. Come on. Shoe dot count dot must equal 1. So now I'm saying do a search through the word database using the word active record word class. I'm going to look for things with the English part shoe, and I better find exactly 1, not 0 and not more. Okay, so now I can go back to my test and run it again. And now I have 6 assertions. Why? Because I didn't add an assertion. I didn't add a test, a run, but I did add 1 assertion to the test. Okay? And I'll pick up here on Tuesday and finish the rest of it, because there's a lot more good stuff. All right, so with that, let me tell you about next week. Oops, that's the wrong course. So, next Tuesday, on popular request, we're going to talk about authentication. And there's a bit of homework, but it's team homework, so let me explain this. First thing is read about the Grails at MinGem. It's very simple, and put it into your product. Every individual member of each product team writes at least 3 mini-test specs for the product. Your deliverable is commit the latest version of your product to GitHub. That's a team deliverable, which means 1 person on behalf of the team can do it. Everybody else gets the same score for that homework. And then an individual deliverable is your source file with the test that you wrote. Okay? Second, and this is more difficult. Read chapter, this is according to the plans that we established last class. Read chapter 14. This homework asks you to apply all the techniques that from that chapter, this homework, from that chapter to your product. I've indicated how the work might be divided up. If you finish with your part, you need to offer to help the other team members to make sure you guys finish. So suggest that you all work around the table on your section so you can help each other. Check your code into GitHub regularly to allow sharing. Do not use the device gem. Follow the model in the book. The device gem leads to suffering. Okay, decide with your team first before you do anything. What can an admin user do and not do? It can be very simple, right? An admin user can create a user. Boom. Nothing elaborate, just one thing that you want to make sure is only allowed by the admin user. What can a regular user do and not do? Doesn't matter what it is. And then finally, what can someone who is not even logged in do and not do? It can be something very, very trivial. With that knowledge, team member 1 create a user model on the same line as the chapter. Anyway, I won't read it to you, but I have a little bit for each team member. And so in this case, you're welcome to copy the code from the book, but it won't help you. But use the book. If you decide you want to go back and do the exercise the way it is in the book, that's fine. But the book certainly will provide you an exact model, but your code will be totally different. Okay? Sorry I ran over. Thanks.
You actually have 2 minutes.
Pardon?
Yeah, you have 2 minutes.
I have 2 minutes. Oh, I assumed that because he left that I was over.
You have to go take a test.
Huh?
You have to go take a test.
Okay, no, it's okay. But that's okay. It's a good breaking point. And so the team deliverable would be only one deliverable for a whole team. Link to your GitHub account. So submit that and submit a screen capture demonstrating what you implement works and that's run. Has everybody done a screen capture? Because there's been another homework with that.
Just so you can discuss.
No? Haven't there been another homework with that? Okay. I have instructions.
So
Screen cap.
you can access it 9.
I have okay, I have 1 more minute. I have instructions on how to do a screen cap. It's very simple. Huh?
Just so you can.
They're like movies, so you like.
It
So
gives
basically
like
is, the way you do a screen capture is a free website called Screencast-O-Matic, and you just start it, and then you do as if I'm standing over your shoulder and you give me a demo. So talk, but it doesn't have to be in any way structured or formal. It's just like, okay, now I'm gonna run it. See, I clicked it here, it works. See, I clicked it there, it works.
There's an easy way of doing that if you have QuickTime. For Mac.
No, because I don't want you to have to upload that big file. Here you get a link.
Okay.
Been there, done that. So Screencast-O-Matic will give you a link with the resultant movie, and then you can put that in your homework. It's really easy. People sometimes get like tongue-tied and they just show. Don't worry about it. It's as if I'm standing next to you and you're showing to me. It doesn't have to go more than 1 or 2 minutes. The point is to illustrate that the thing works. Okay? Thank you.